Welcome to Math with Mrs. Bibb. Today we will be solving systems of equations in three variables. First of all, we will discuss what the solution to a system of equations in three variables looks like, and that's what's called an ordered triple. The definition for an ordered triple is three numbers given in a specific order to locate a point in space. We are used to the normal x, y axis, and when you have an ordered triple, you add the third axis, which is called the z-axis, which is when you're talking about a three-dimensional plane. To solve a system of three equations, you have a series of steps to do. If you'll please write those down on your paper. Number one, you'll do elimination with the first two equations. When you do this first step, you'll choose any variable to eliminate. Number two, you'll do elimination with the last two equations, and you must choose the same variable as step one. Number three, do elimination with step one and step two. This will give you one answer. Number four, substitute the answer from step 3 into the equation from step 1 or step 2. This will give you the second answer. And then step 5, substitute the answers from step 3 and step 4 into one of the original equations to find the final answer. And be sure to write your answer as an ordered triple x, y, z. For our first example, we are going to follow those steps that you've just written down. We are going to use the first two equations. Please make sure to write out step 1, step 2, step 3. It will help me be able to find your mistakes that you could possibly make. So we get to eliminate whatever variable we would like. And as I look at this, I would choose either y or z to eliminate. And the reason why I would do that is they are already opposites of each other. You could also choose x, but you will have to multiply by a negative. So I am going to choose y in this case. I am going to multiply the top equation by 10 and the bottom equation by 1 and put those answers over here. So 40x plus 10y, be very careful when you do this, plus 60z equals 120. 2x minus 10y minus 2z equals 12, and add those together. And I will have 42x, my y's are eliminated, plus 58z equals 132. That is my answer to step 1. Step 2. I must eliminate the same variable, so I have to eliminate y. To eliminate y, I'm going to look at the coefficients, negative 10, positive 8. I'm going to think about the least common multiple of those two, and I do believe that would be 40. So I'm going to multiply the top equation by 4 and the bottom equation by 5. I'm going to go ahead and write step 2 in blue, so you can see that's what the result of the blue multiplying. So I'll have 8x minus 40y minus 8z equals 48. For my bottom, I'll have 15x plus 40y plus, let's see, 20 times 5 would be 100, so that would be 95. 95z equals 190. And then I'll add these two together, and I'll get 23x. These go away. Is that 87z? Think so. And then 8, 13, 238. Okay, and now step 3. Oh, I'm highlighting. Oops. Did not mean for that to be a highlighter. I'm going to take the answers from step 1 and step 2 and do elimination, and this should be fun. Let me pause and think about that for a minute. Okay, I finally used some skills from like 7th grade to figure out what would be the least common multiple, the easiest one to find. And so I'm going to eliminate z, and I'm going to turn this coefficient into 174. So what do I need to multiply 174, what do I need to multiply 58 by to turn it into 174? And that would be 3. And what do I need to multiply 87 by to turn that into 174? And that would be 2. And those two coefficients are not opposite, so I'm going to multiply the bottom one by -2. So I'm going to have 126x plus 174z equals, I believe that's 396. Yes, 396. I'm going to have negative 46x minus 174z equals negative 476. I'm going to add these together. That's 80x, these go away, equals negative 80. I'm going to divide by 80, and x will equal -1. So in my solution, I'm going to put it up here. I know x is -1, and I'll keep going to find the next one. So for step 3, what I'll do is I'll take -1 and put it into one of the equations, either step 1 or step 2. I think I'll put it into step 1. So 42 times -1 plus 58z equals 132. Negative 42 plus 58z equals 132. I'll add 42 to both sides. 58z will equal 174. Divide by 58. I believe that was +3. Yes. Oops, and this is step 4. And then for step 5, we will take these two answers and put them into one of the original equations. I like to pick the ones with the smallest numbers. I think I'll just use the first one. So I am going to, for step 5, I'm going to use 4x plus y plus 6z equals 12. I know x is -1. I do not know what y is. I know z is 3, and I'm trying to find y. So I'm going to multiply. Going to add like terms on the left-hand side. So y is going to equal 14. Y plus 14 is going to equal 12. Subtract 14. So y will equal -2. Let me go back just for a second. Z was 3. I forgot to put that at the top. And y is negative 2. So my solution is negative 1, negative 2, positive 3. Next, what does it look like when you have something special happen? And let's go through these steps and see what happens when we have something special happen. Let's eliminate x for this first one. So step 1, I'm going to multiply everything by 4 on the top and multiply everything by 1 on the second one. So I'm going to have negative 4x plus 20y minus 16z equals negative 8. And then I'm going to have 4x minus 20y plus 16z equals positive 8. Negative 4x and positive 4x, when you add them, go away. 20y plus negative 20y, that goes away. Negative 16z plus 16z, that goes away, so I'm left with 0 on the left. Negative 8 plus 8 gives me 0 on the right. This is a true statement, so the solution to this system of 3 equations is infinitely many solutions. And if you had gotten a false statement, so if this were false, which it's not, so then it would be no solution. But we know the red one is the correct answer to this problem, infinitely many solutions, because we got a true statement. And for the next problem, I typed this one incorrectly. There should be a 4 here, so if you'll please make sure to write that there so we'll have that correct. Step 1, I am going to eliminate the g's. I'm going to multiply the top by 1 and the bottom by 4. So f plus 4g minus h equals 1. 3f minus 4g plus 32h equals 0. Add them together. 4f plus 31h equals 1. And then I will do the same thing for the next one. I will multiply this one, the second equation, by 4. And the bottom equation by 1. So I will have 12f, this is step 2, 12f minus 4g plus 32h equals 0. And then I will have f plus 4g minus h equals 10. And I'll add these together. 12f plus 1f is 13f. These go away. Plus 31h equals 10. Step 3. I will multiply this one by positive 1 and this one by negative 1 to eliminate the h's. So 4f plus 31h equals 1. Negative 13f minus 31h equals negative 10. Add them together. Negative 9f equals negative 9. Divide by negative 9. F should be positive 1. So remember F, G, H in our order triple. So positive 1, and then I'll see about the other two. step 4, I will substitute 1 into the equation. I'll substitute it into the answer to step 1. Multiply by 4. Subtract 4. Sure got a fraction, which seems very weird, but we'll just go with it. Make sure I didn't make a mistake. Doesn't appear that I did. And now let's take the answers and put them into one of the equations. I'll just use the top one. F plus 4g minus h equals 1. So 1 plus 4g minus 3 over 31 equals 1. I think I actually found a mistake here. I did not multiply in step 1. I did not multiply this by 3. So this should be 12. So get ready to erase. I'm going to have to erase 2. I don't think I can. I'll just write over it. So this should be 12, and this should be 13. And then this should be 13. And these should go away. Yep. See, all of this is incorrect, but that's okay. I'm sorry, you'll have to erase. So I would have 0 equals -9, which would make this no solution. So there's a mistake. The answer to that one is no solution. Sorry about that. See how easy it is to completely miss, and I'm sure some of you caught that as I was doing it, and maybe you didn't. So just be very careful. You have to distribute that number to everything, and I did not. I forgot to do that. Okay, moving right along. Okay, I have 2 examples here. They're both from your textbook, and I want to talk about number 9 first. When you're doing one like number 9, the solutions are M, N, P. Please be aware that when you're given something like this, you know one of your solutions already. So we know P is 1. My next word of advice, I'm not going to do this whole problem for you, but my next word of advice would be to take this P value and put it here and subtract this value to the other side. And then you'll have 2m plus 5n equals this value, and 5m minus 7n equals -29. And then you'll have a system of 2 equations, and you'll be able to find your m and your n. So write yourself a note, substitute P into first equation and simplify, and then solve the system of 2 equations. That will give you your 2 that you're missing. And then the other problem is this one here. There's a couple ways you could approach this. You could solve these 2 together. It's a system of 2 equations. And you could solve and find your x and then find your z, or vice versa, and then substitute those 2 into the original to find the y value. So you could solve these to find x and z, and then substitute here to find y. The other thing you could do, and I've seen many students do this, is you could rewrite that this way. 13x plus 0y plus 2z equals 2, and negative x plus 0y minus 5z equals negative 5. And then you would want to do those 5 steps the way we normally do. And don't eliminate y, because y is not in the last two equations. So do normally eliminate x or z. And then you would be able to find all three of the values. So it's totally up to you as to how you would approach a question like that. And one more example. So in this example, we have write and solve a system of equations to determine the number of new individual memberships. So that's the first thing we want to do, is write and solve that system. I have written out defining the variables, although they are defined in that last sentence there. So first thing we're going to do is write a system of equations. So in 1 month, the museum sells a total of 81 new memberships. So total of 81 new memberships means you add them all together and you will get 81. It says the number of dual memberships purchased is twice that of individual memberships. So the number of dual memberships, which is y, is twice that of individual memberships. And then the last one, $60 times x plus $80 times y plus $100 times z equals 6,420. Now, this is not a traditional system of three equations. Where I'm going to start is I'm going to substitute 2x into both of those equations. So x plus 2x plus z equals 81, and 60x plus 80 times 2x plus 100z equals 6,420. That would give me 3x plus z equals 81, and this would be 160x. So 60x plus 160x which is 220x. I'm going to erase that. Plus 100z equals 6,420. Okay, I am going to multiply the top by 100 and the bottom by -1, and I'm solving for x. I do want to say make sure you wrote down this problem on your paper along with all the work that I have. That way you'll have that problem written down. And I'm going to have 300x plus 100z equals 8,100. And I'll have negative 220x minus 100z equals negative 6,420. Then I'm going to subtract, I believe that would be 80x. Those go away. I get 1,680 divided by 80. X will equal 21. Okay, so I'm going to put the order triple up here. 21 goes here. I know y equals 2 times x. So y equals 2 times 21, which is 42. And then I know 21 plus 42 plus z equals 81. And that is what, 63 plus z equals 81. Whoops, and I wrote 18. Subtract 63. So z is going to equal 18. To finish this out, we will say the museum sold 21 individual memberships (42 dual memberships and 18 family memberships. And that is my final answer. I'll grab a highlighter and just highlight around it. That is my final answer to this problem. I hope you have a wonderful day.